Hello students, welcome to the next lecture on the linear algebra. Today we will discuss about all those questions related to these topics from the year GATE 2019. Myself Dr. Harish Garg. You can simply follow my YouTube channel and scan and join my WhatsApp group through this barcode. You can also see the various lectures about the linear algebra and the GATE solutions in my YouTube channel at here. So let's start with this video. So how you can approach this question? Remember always you have to read the statement very carefully and then you can solve the question within a 15 to 20 seconds as usual. If you read this statement carefully, a function is given to you and they are talking about the maxima, minima, saddle point. What is the tips for you? Remember, a function in this case is a two variable. It may happen that in the next examination they give as a 3 variable. How you can check about the maxima and minima? Remember, the very simple tips is you have to construct a matrix A. If it is a 2 variable, then it is my 2 cross 2. If it is my 3 variable, then you can construct as a 3 cross 3. How you define the elements? The first element is fxx, second is xy, this is yx, and this is yy. If it is of the 3 variable, then how you can define? The first row is with respect to the x, so fxx, fxy, and fxz. Second line is with this y with respect to x, y with respect to y, y with respect to z. Third line is z with respect to x, z with respect to y, and z with respect to the z. If it is a 4 cross 4, then you can write as a 4 cross 4 matrix here. Now you have to compute this matrix at the point x0, y0. Then the condition is for the maxima, when it's condition for the minima, and when it will be the saddle point. Remember, this is a generalized trick. You can solve any question with the help of these shortcut tricks. First one is the first element if it is a less than 0, the first element if it is a greater than 0, and the first element it is a 0. Either of the satisfied, then we call as the max, min, and the saddle point. The second property is if you find the determinant of this, it will be greater than 0. The determinant of this is greater than 0. Because it's a saddle point, it can be greater than or it can be less than. So we will see about here. You can see the point is already given to you as 0, 0. So what is the fxx? So firstly we need to find the fx. What is the partial derivative? It's a 6x raised to power 5 minus, there is no need to find. Moreover, okay, firstly I will find you and then we will tell you again the simplest way. What is the fxx? It is my 30x raised to power 4. It's a 4y minus 12x square y. So what is the value at the origin? 0, 0. So fxx is my 0. So once it's a 0, it satisfies this property. So it's a saddle point is the right answer. So the correct answer is my C. Otherwise there is no need to find this second derivative. You can see the degree of this is my 6, degree of this is my 3, degree of this is my 5, degree of this is my 2. So when you consider this as a second derivative, definitely this part will be 0, this part has a degree 3, this part has a degree 1, this part has a degree 4. So at the origin its value will always be a 0. So this is the way you can solve this as here. If you find that this value is less than 0, then you can check whether the determinant is greater than 0 or not. If this property is not satisfied, then we call this as a saddle. Okay, look at this next question. F is a degree polynomial of at most 2. At most 2 means less than equal to 2. Remember, equality is the most important thing. If some question said f is a polynomial of degree less than 4, you can see it's a less than 4. That means equality is not be there. So you can write as a less than equal to 3. So what are the bases of less than equal to 2? The bases are 1, x, and x square. These are my bases. Now you can substitute the f is my 1 here, 0. This is a, this is 2, this is b. So from here you can see a plus b is equal to minus 2. But we need a 4a plus 3b, but we can't find that. So this option is cancelled out. Look at that, when f is equal to x, left hand side is 1, this is my ax, this is my twice of x plus 1, and this is b times x plus 2. Then you can equate the coefficients. There is a constant on the both sides, that's a 1. This is my 2 plus 2b. This is a 2 and plus 2b. And when you equate the coefficient of the x on the both sides, it's a plus 2 plus b. So from here you can find the value of the b is my minus half. From here this is a plus 2 minus half, 3 by 2, a is my minus 3 over 2. So once you will find here, you can substitute the value as here 4a plus 3b. What is the 4a is minus 6, 3b is minus 3 by 2, minus 7.5 is the right answer of this problem. That's a very simple target for you as here. Okay, look at this another question. This is a question related to the line integral. A circle of radius 2. This is my circle of radius 2, center at the origin. Then is the anti-clockwise. So this is the curve of there. Okay, that's a very simple. Whenever there is an equation of this form, how you can solve that? I think all of you know that you can use convert into the double integration, partial derivative of n with respect to here, m with respect to y. I think you can remember what is the result of this. That is called as the Green theorem. Fine. So this is my m, this is my m. So what is that? Double integration partial derivative with respect to x, 4y square, minus partial derivative with respect to, it's a minus, it's a 4x square, it's a dx dy. So I can written as a 4 double integration of x square plus y square. Now since it is the equation of the circle, I can change into the polar coordinates. So double integration, it's a r square. What is a dx dy? It's a r dr into d theta. So what is the limit is? It's a 0 to 2, it's a radius, and theta is my 2 pi. So what is that? It's a 4. What is that? It's a r cube. So it's a r4 over 4 from the limit 0 to 2 and from the limit 0 to 2 pi. So what is that? 4 will be cancelled. So it's a 16 into 2 pi. 32 pi is the right answer, and L by pi is my 32 is the correct answer of this problem. It's a very simple. You can simply change whenever there is a question related to this form. You always convert, whenever there is a equation of this form, you convert always into the Green theorem. Okay, look at this another question. The temperature at any point is inversely proportional to the square of the distance of the point P from the origin. So that is a square of the distance. So I can say it's a, what is the distance is x square plus y square plus z square, and I can remove this constant as a k. How you can find this value? The value of the temperature at the point 0, 0, 1 is my root 3. So if I substitute here, what will happen? K is my root 3. So what is the temperature? The temperature will be my root 3 over x square, y square, z square. Fine. Now then the rate of the change at the point this in the direction of this. Basically they are talking about the directional derivative. So the gradient of the t into the unit vector of this QR. Firstly I can find the position vector of the QR. That is r minus q. R is my this, q is my this. So I can say it's a 1 I cap, 1 j cap, 1 k cap. What is the unit vector of this? This is divided by root 3, I, j and k. Fine. You can also say it's a minus of this, so I can take as a minus common. There is no problem about it. Now how you can find the directional derivative? You can take the partial derivative with respect to x. So what is that? It is root 3 x I cap over whole square plus root 3, it's a minus, you can take as a minus common, there is no issue. So it's a minus y over whole square of j cap plus minus 3 z over whole square k cap. At this point, what is the gradient? At this point, minus root 3 over this point, there is a 4 plus 5 plus 1, 36 is a common, it's a 1 I cap, 1 j cap, 2 k cap is a common. Now take the dot product of this. Minus minus plus, minus root 3 by 36 root 3, 1 plus 1 plus 2. So it is a cancel out. Minus minus plus is a 4 divided by 36. 4 divided is there, it's 4, sorry, it's the derivative will be 1 by, it's a 2x, sorry, it's a 2x, so 2 will be common in the each case. So 2, it's a 8 by, so it's a 4 2 4 9, it's a 2 over 9. What is the answer of that 2 over 9? Up to the 2 decimal places, 0.22 is my right answer of this problem. Now look at this another question. What is given to you? F is a continuous function such that here area bounded by area, that is a f of x dx over this is given to be here b square minus root 3. What is the meaning of that? If you have the curve, this is say function, this is x is equal to b, then this is the area, this area is given to you here. Then you have to find the value of the f of 1. So the basic purpose is to find the value of the fx firstly. That's a very simple. If you look about this right hand side, you can clearly see is I can write this function as 3 plus x square from the limit 0 to b. Fine, it is fine. So what is the meaning of that? It means when you integrate this fx here, the answer of this will be here. Fine. So what is my fx? So you can see f dash, what is that? If you take the derivative of this, so it will be my x over 3 plus x square. So basically it is my x. Fine, that is my here. If you differentiate on the both side, it is my here. So now what is the f of 1? 1 over 4, 1 over 2. So the right answer is 0.5 is the correct answer of this problem. You can see it's a very simple question. You can think about this term conceptually, is the right answer within a fraction of second. Okay, now look at this another question. The characteristics polynomial of any square matrix is my here. Minimal polynomial of the matrix A is given to be here. Fine. This. Now, what are the eigenvalues of this? You can see the eigenvalues are my plus 1, minus 1, plus of 2, having the algebraic multiplicity 1, 4 and 5. Now you can see it has a degree 1, that is a minimal polynomial is linear. What is the meaning of that? The matrix is my diagonalizable. Fine, because if whenever the minimal polynomial is of the linear nature and consists of all the eigenvalues, then it is a diagonalizable. One is a diagonalizable, then what is the meaning of that? Then this A matrix is symmetric to the diagonal matrix. So what is the diagonal matrix? If you consider here, diagonal matrix is only consists of the diagonal entries which they have the eigens value. So what is the eigenvalue of the A? 1 is occurring 1 times, it's a minus 1 occurring 4 times, 2 occurring 5 times. Fine. Then your target is to find the rank of the A plus I. What is the eigenvalue of the A plus I? I can add 1 on the both sides, 0, 0, 0, 0, 3, 3, 3, 3 and 3. Since A is my diagonalizable, then you can find the rank of this matrix A as number of the non-zero eigens value. So similarly, how many non-zero eigenvalues are there? 1, 2, 3, 4, 5, 6. So the rank of this matrix is my 6 is the right answer. Remember, whenever A is the diagonal matrix, then you can write as the rank of the matrix as the number of the non-zero eigenvalues. Okay, look at this another one. M is my 3 cross 3 symmetric matrix. Fine. Having the eigenvalues, so there are the 3 eigenvalues. One is a 0, second is a 2, third one is my A, which is unknown. Having the respective eigenvectors are there. Fine, that's very simple. Once the matrix is symmetric, what you can say, the eigenvectors are orthogonal to each other. We all know orthogonal. So what is the meaning of the orthogonal? U dot v will be 0, v dot w will be 0, and u dot w will be 0, but provided one condition. What is that condition? Is if u dot v is my 0, then it means the eigenvalues are unique corresponding to the eigenvector u and eigenvector v. If the dot product is a non-zero, then the eigenvectors are repeated. Fine. Now we have to firstly check whether a, what is the value of the a. So what is the u dot v? So u dot v must be 0, so it is my -4 plus 2b plus 0 is equal to 0. So b is my 2. Fine. I can also see this into this. So u dot w is equal to 0. What is the meaning of that? 4 plus b plus c is equal to 0. C is equal to -6. You have the b, you have the c. Now your target is to find the value of a. Now what is the v dot w? So it's -1 plus of 2 plus 0, which is 1, which is non-zero. So now you can see this value is non-zero. So what is the meaning of that? Eigenvalues are repeated of w and the v. This is the eigenvector corresponding to u, this is the eigenvector corresponding to v, this is the eigenvector corresponding to the w. They have the same repeated vector. So what is the meaning of that? A value must be of my 2 is there. Fine. So we get a as my 2, b as my 2, c as my -6. So what is that? A plus b minus c is the 10 is the correct statement. So 1 is the correct state. Now look at the another one. Now you can see about the trace. So m, what is the eigenvalue of the m? So eigenvalue of the m is my 0, 2 and 2. Fine. So what is the eigenvalue of the m square? 0, 4, 4. What is the eigenvalue of the m square? Plus 2m. It's a 0 plus it's a 0, then 4 plus 4 is a 8, 4 plus 4 8, and the trace is my 16, but he said 8. Fourth option is cancelled. So this option is cancelled, this option is cancelled. So we need to only check about the third option, because second is in both the cases is the correct statement. So look at that, how you can think about this third option. Mx is equal to d has a solution. When it will be a solution? Either it has a unique solution or it has a infinitely many solution. Fine. Now for any d which lies in the span of this, so you can think about any of the span. Firstly, what is the rank of the m? 2, because one eigenvalue is 0, so the rank of the m is 2. So if I prove rank of the m cross d is also 2, then only it has a solution. Now what is the value of the d? This is the span of this, and it's said for any combination of this. So I can simply take what is the span of this, that is the alpha 1 u, alpha 2 v, alpha 3 w. So clearly says the last vector is my 1. If I consider this value is my 0, this value is my 0, then, or this value is say my 10, this value is 0, this value can be anything, say 1, then the last element is always be a 1, and whatever the elements are here. So it means the rank of this is my 3. So what is the meaning of that? It has a no solution. So once the third has a no solution, it means this option is cancelled. So the first and the second are my correct options. How you can check about whether the second is my correct option or not? You can again see, your target is to find mx is v plus w, vector is my here. So firstly I can find the v plus w. It's a 0, it's a 3, it's my 1. Fine. Now look at that. If you think about mx is equal to say any vector, say x dash, if I prove this can be written in the form of the lambda x. What is the meaning of that? Lambda is the eigenvalue. Eigenvalues are my 0 and 2. So it means I can written either in the terms of 0 into x, or I can written in the terms of the 2 into x. Then only I can say it has a solution. Now you can see about that. X is my 0, 3 by 2, 1 by 2. Can I written this in terms of here? 0 I can never write because it's a 0, 3, 1. So if I take 2 as a common and this is my eigenvalue, so it means this has a solution. This is the eigenvector, so it has a solution. So it means this is my correct statement. So first and second are my correct statements. So the right answer is my B is the correct option. Okay, look at this another one. P2 is a polynomial of degree, again it's at most 2. So the bases are my 1, x and x square. Fine. Then which of the following statement is my true for this polynomial? Null space. What is the null space? T of A is my 0. That's my null space. There is no need to solve this problem. The first method is you can write this value B minus C plus A plus C x square is equal to 0. Equate the coefficient on the both side, this and this, and you can solve this. You will check whether this is the form or not. But a very simple shortcut text for you, instead of solving this manner, there is no need to solve that. You can see that if you compare this value with here, A is my minus alpha, B is my alpha, C is my alpha. So alpha can be anyone, so I can choose alpha is my 1. So A is my minus 1, B is my 1, C is my 1. If I substitute here, we can check whether this property hold or not. A plus B, 0. B minus C, 0x. A plus C, 0x square, but is a 0. So it means yes, this is a null space. It's a correct state. Fine. Or otherwise, if you solve them, you can see B is equal to C, A is equal to minus C, A is equal to minus B. So B is equal to C, so I can written this as a minus C. Again, you can see all the pairs in this manner. Look at the second option. How you can think about the second? The range space. What is the meaning of the range space? Is T of A is in the my domain P2. Fine. What is that? This is the here. So again, a very simple. I can see about this pair. This is given to you, A plus C x square. Now if you take the constant, I can write what is the coefficient of the, what is the constant? It's only 1. What is that? It is my here. Or you can take pair of the A. What is the pair of the A? 1 plus x square. What is the pair of the B? 1 plus x. What is the pair of the C? X square minus x. So it means it is the combination of linear combination of this one. Fine. Now clearly says with the help of these two you can generate this one. If you add them, you can generate this. With the help of these two you can generate this third one. So what is the meaning of that? It is the span of any two vector. So in the given statement they are talking about this. So yes, this is the correct state. Fine. So the first and second both are correct. So in this case there are only, but first is also the correct, it's a cancel. Now in this case here. Now look at this third option. What is the given to you? You have to prove T of T 1 plus x. So what is the 1 plus x? That means A is equal to 1, B is equal to 1, C is equal to 0. So what is that? If you substitute here, A is equal to 1, B is equal to 1, it's a 2, B and C it's a 1, A and C it's a 1. Now again in this case A is equal to 2, B is equal to 1, C is equal to 1. So A plus B 3, but clearly say that it's a 3 but it's a 1, it can never be same. So B minus C is a 0x, A plus C is a 3x square. It's a 3 times. It's a 3 times of the x square, but it's a 1 plus x square. Third option is cancelled. So this option is also cancelled. Now we can check about the fourth option. Fourth is a very simple. That's I already explained many times. You have to write the matrix representation. What is the basis of this is? It's a 1 x square. So there is a 3 cross 3. So if I take the polynomial as my 1, so what is that? A is equal to 1, rest are 0. So this value will be 1, this is 0, this is 1. So 1 0 1. When you consider polynomial as a x, so a is my 0, b is my 1, c is my 0. a0 b1 is a 1, it's a constant. b minus c is a 1, a plus c 0. When you consider p as my x square, it's a is 0, b is 1, b is 0, c is my 1. So a plus b 0, b minus c is a minus 1, a plus c is my 1. Then the trace of the matrix here, what is the trace of this? Trace is my 3, and it's also say 3 is a correct statement. So the right answer is C is my correct option, rest options are my cancel. Okay, look at this another one. Let V is the matrix of the 3 cross 3 of the complex entries such that is collection of all those, and here that is what is the meaning of that? That's a Hermitian matrix. Fine. So what is the kind of this matrix? It's a 3 cross 3. Whenever A and A transpose same, so if you look about the diagonal entries, this is my diagonal entries. So what is the meaning of that? This part will be 0. So the diagonal entries are my A11, A22, A33. Now since these are the Hermitian, so if I write here as a 1 2 plus iota 1 2, then this value will be A12 minus iota B12. Similarly, if I write the third pair, this is my A13, B13, this is the same as with the negative sign. This is A23 minus B23, this is the same negative sign. Fine. Now you have to find the dimension of W1, because how you find this? We have to write the dimension of this minus dimension of this intersection. So what is that? How many elements are there? 3, 4, 5, 6, 7, 8, 9. So the dimension of this is my 9. Fine. So this is my 9. What is the W2? Trace of this A is my 0. Trace of A is my 0. There is no condition of the Hermitian are there. So I can write this is A11 plus iota B11. Similarly, A12 plus iota B12, A13 plus iota B13, and so on. Now, what is the meaning of the trace of A is 0? It means A11, A22, A33 plus iota times B11, B22, B33 is my 0. What is the meaning of that? Summation of the AII is 0 and BII is my 0. So what is the dimension of this? W2. How many total elements are there? 18. There are the two conditions given to you. You have to write as a minus. So the condition is my 16. This value is my 16. Now, how you write the intersection? So the intersection will be, you have to write the common portion of this. So what is that? Intersection will be A11. What is the meaning of the intersection? That is a Hermitian plus trace of the matrix is my 0. So this is the Hermitian, this is the Hermitian, and apply the condition of these diagonal elements are my, so trace of them will be my 0. That is A11, A22, A33 will be my 0. Fine. This is the Hermitian plus trace of this is my 0. So how you can find this? How you can find the intersection? The total 9 elements, one condition is here, so the dimension of this is my 8. So you can see what is the right answer of this is the 17 is the right answer of this problem. Clear? So I repeat them. These are Hermitian plus trace. So that means there is a one more condition. So total 9 elements are there, minus 1 additional condition. So minus 1 is the dimension of the problem. Okay, look at this another question. Consider the inner product of the P2. Again the degree is my here 1x and the x square, or it is in the form of the t, so 1t and the t square, such that f0, f1, f2 are my orthogonal. Once is orthogonal, so the inner product will be my 0, f0, f2 is my 0, and f1, f2 is my 0. f0, f1, f2 are given to you, then you have to find the values of the c1, c2, c3. That's a very simple. f0, f1. f0 f1 over the integration 0 1. So that is nothing but here. So integration of this is half plus c1. So the c1 will be my minus half. f0 f2 inner product will be 0. Fine. So that's the integration of this is my 1. So it's my here. So you can integrate this over the f0. So clearly say when you take integration, it's a 1 over 3 integration of this. It's a f0 into f1. f0 into f1 is my 0. So the coefficient of this is my 0. And the integration of the c3 is my here. So the c3 will be my minus 1 over 3. Fine. Now the third condition is my f0 f1. So what is the f0 f1? So f1 I can written as t plus c1. I can written as f0. Fine. Dot product of f2. f2 I can written as a t square plus c2 f1 plus c3 f0. Why I written as f1 f0? I can use this property. So look at that. When I multiply this portion into this, f1 f2 0. When I multiply okay, so now if you multiply them, it's my t cube plus this I can multiply here, it's a c2 t of f1 plus c3 f0 is my 1. Now this portion plus c1 t square, this portion will be 0 and this portion will be c1 c3. Now you can integrate over the 0 1. So this value is my 1 by 4 plus what is f1? f1 is my t plus c1. So I can t into t plus c1. T square, it's a 1 over 3 c1 over 2. c1 is my minus 1 by 2. So 1 over 3 minus 1 by 4. It's my 1 over 12. It's my c3 over 2. It's my 1 over 3. What is the c1 c3? It's my plus 1 over 6. Now you can see c3 is my minus. This value will be cancelled out. c1 is my minus 1 by 6. So answer of this is 12 is the LCM. It's a 4. This is c1 over, sorry, it's a c2. It's a c2. So 1 over 4. c1 is my minus. So it's a minus 1 over 6 plus c2 over 12 is my 0. So what is that? It's a 12 is the LCM. 3 minus 2 1 plus c2 over 12 is 0. So the c2 is my minus 1. I can substitute here 2c1 minus 1 minus 1 minus 1. Right answer of this problem is my minus 3 is the correct answer of this problem. So that's a very simple. You can use the property of the orthogonal. You can make this calculation as much simple you can, so that your calculation will be reduced. So I hope you can simply learn the various tricks in this video as well. We will see the next lecture on the GATE 2020 linear algebra questions as well as the real analysis. Till then you can simply scan and join my WhatsApp group. I hope you can like, share and comment on my video. Best of luck students. Happy learning.